Part of talking about properties of logarithms is the idea that we use the properties of logarithms to get our expression into one log so that we can use the change of base formula. So the idea about logs is that most of you have calculators that do not support logs of any base other than base 10. We talked a little bit about common logs in a previous video, but your calculator should have a button with the word log on it. This log is the common log. This is log base 10. Fortunately, when you're presented with something like log base 3 of 8, there's no way to put that in this calculator as is. What the change of base formula allows us to do is convert this into a format that can be evaluated using your calculator. We just need to make it look different but mean the same thing. So the change of base formula changes the base from 3 into base 10, or common log language. So the idea is we take a logarithmic expression like this, and we do a common log of the argument, and then we divide that by the common log of the base number. Now, you cannot treat this like a normal fraction. This is not log over log times 8 over 3. This is log of 8 over log of 3. This is all one piece. You can't cancel out these words log, and you can't do 8 divided by 3. You have to do all of this in the numerator divided by all of this in the denominator. Another quick note is that you have to be very careful of how you plug this into the calculator. Different calculators do things different ways, and so you want to make sure that you're familiar with the calculator that you're using. But if you're using a calculator that looks like mine, this is the kind that I suggest in the syllabus, you're going to hit the log button, and it's going to show you, similar to how it's written on the page, log of a number. When you tell it what to take a log of, you have to close the parentheses around it. Otherwise, what you say to the calculator is that you want to take a log of 8 divided by log of 3, which is a very different calculation. So just remember to close the parentheses around that, and then you hit divided by log of 3. And you close the parentheses. Often this is a very complicated decimal, and generally it's a good idea to round to at least 2 decimal places, 3 if you can stand it. So I would probably go all the way out to 1.893 here. Now what does this mean? Remember that a log asks a question. It asks, what exponent would I need to raise my base to in order to turn it into the number 8, which is my argument? A log solves for an exponent. It searches out an exponent value. So this is the answer to that question. We would need to raise 3 to this power to turn it into 8. Now, granted, it's actually this great big long complicated number, but if I check my answer, if I raise 3 to this power to see if it turns it into 8, it's going to get me darn close. 3 raised to the, I'm going to just put it in parentheses, it's hard to see, raised to the 1.893 power. See how close that is. And the reason it goes over 8 is because I rounded up. So it's going to make this number bigger than it should be. But that's the idea, is that once you get your log down to one thing by using the product property, the quotient property, or the power property, once everything's inside, we can then use the change of base formula to solve.